Hello and welcome to Exponentials 4.1, solving basic exponential functions, or equations rather. Okay, so let's get started. So we're going to solve for x basically, but we've never solved for x when it's in this particular spot. And when I say this particular spot, I mean the x is actually an exponent. Yeah, so we've never had this encountered before, so this is going to make this problem a little bit different as far as how it starts off. But eventually when I show you guys how this actually plays out, you're going to be like, oh, wow, that's it. I've done this kind of a problem tons of times, so it's not going to be that bad. Okay, so here we go. Okay, so we're going to solve for x, and right now we have the x right here in this left side, the left side of the equal sign, and it's an exponent. Yeah, so we'd never had an x there before. So how do we solve for an x that's not normally in that position? Well, it's pretty simple. Okay, and yeah, basically you're just going to ask yourself this question. Yeah, if you look at the left and the right side, you notice that they have a base 2 on both left and right side. So it's basically they share that in common. Yeah, so I mean there's a really technical explanation as far as why I'm going to be able to do what I'm going to be able to do, but basically the simple explanation is basically this: they cancel each other out. Okay, so you're going to use basically logarithms. Yeah, and you're going to use I guess some of the qualities of logarithms to cancel out these 2's that you see on the left and on the right side. Okay, so the main thing you got to make sure is for this to happen, you have to have the exact same base on both sides of your equal sign. So base 2 here, so we're all good. Okay, and if that certain condition exists, then through the use of logs that we're going to give to both sides, they can basically cancel each other out. Okay, so watch what this problem turns into as a result of using logs to cancel out those two base 2's. Okay, and when you see what happens, you're gonna be like, wow, that's like pretty easy now. Okay, so after the 2's cancel out, you basically have this left. Okay, so the exponents just transfer into your problem. Yeah, they turn into your problem basically because the 2's, yeah, the base 2's, they cancel out, they go away, they disappear. Yeah, and now you just have to solve for x. So solve for x like you've normally been doing. So let's get rid of this 5. Yeah, so how do I get rid of the 5? Just subtract 5 both sides. And then we get 3x equals 2. So then you divide by 3. And you get x equals 2/3. And there you go, that's your answer. Pretty simple. Yeah. Main thing though, the takeaway here is this now. Yeah, this can only happen, right? You can only cross out these 2's if you see the same exact base on both sides. And the way that you make them cancel out is basically you're going to use logarithms. So I'm not going to really show you the process behind using logarithms, okay? It's just that you're just going to use logarithms to get rid of them. Yeah. So if you have more questions about how logs actually work, I can answer that kind of stuff later. But for now, yeah, without getting too technical, yeah, just understand that we're using logs to make the 2's cancel out. Okay, so let's jump to number 2. So this one, we want to employ a similar strategy, but this time we don't have 2's on both sides. We have base 7's. So will it still work the same way? Yeah, exactly. It'll still work the exact same way. As long as you have the exact same base on both sides, you can use logs to cancel them out. And when the logs cancel them out, yeah, all you're going to have left is x squared on the left side equals 3x plus 10. Yeah, so the logs are going to do its job. They're going to make the 7's disappear, and all you have left is that. Okay. All right. So we have an x squared that we have to solve for now. So this is where you got to remember from your first quarter topics. Yeah, where I told you guys, yeah, that if you see an x squared in your problem and you got to solve for it, yeah, you want to do two things. You want to make sure your x squared stays positive. So you're going to move stuff around. You're going to either move these two things on the left, or maybe you're going to move the x squared on the right. Yeah, but you're going to move something around. So either x squared goes to the right, or 3x and 10 will go to the left. They all got to gather on one side or the other, because you want to have everybody on one side, 0 on the other. Okay, so you're going to have some movement. So as far as deciding who's going to move, though, you want to make sure at all costs your x squared stays positive. Okay, because if you leave your x squared positive, it makes your problem that much easier to solve. Yeah, so should I move this x squared to the right? No, because if I do that, it's going to make negative x squared on this right-hand side. I don't want to do that. I want to keep x squared positive, and since he's positive right now, I'm going to move the 3x and the 10. So I know that's more movement, right? I have to move two things compared to just one on the left side, but it's going to make the problem so much easier. So I'm going to move the 3x and the 10 to the left side. Okay, and when that happens, since nobody's like terms, yeah, well, actually like terms on the right side, that's what I cancel out. So you get 0 on the right side, actually. And since nobody's like terms on the left side, you just get x squared minus 3x minus 10. Okay, and now you just got to solve for x squared. So you're going to use one of your three strategies, which are factoring, complete the square, or quad formula. And luckily this problem can be factored because you can figure out two numbers that make negative 10 when you multiply and negative 3 when you add. So what two numbers make negative 10 when you multiply and negative 3 when you add? Well, that combination will be negative 5 and positive 2. Okay, so if you guys are not too up with the factoring, yeah, just look at my factoring review lesson that I have as well. Yeah, then you guys can brush up on your factoring in case you forgot. Okay, so we got x minus 5, x plus 2 is our factored form of this quadratic. So when we solve for x, we're just going to set each of these parentheses equal to 0, and we're going to solve for each of these x's individually. Okay, so basically, when I solve for this left side parentheses, it is x minus 5 equals 0. Let's get more space here. So x minus 5 equals 0. Add 5 both sides, so you get x equals 5. So that's our first answer. Okay, then the second one, x plus 2 equals 0. So subtract 2 both sides, and you get x equals negative 2. And that's your second answer. Okay, so on this line up here, you just put them in numerical order, negative 2, comma 5, and you're all done. Ooh, actually forgot to put the answer for this guy on this side. And yeah, 2/3 here. Okay, and these problems are done. Alright, so let's move on to problem 3. Alrighty, so what do we got for problem 3? Okay, so once again we have matching bases, right? Base 3 on the left side, base 3 on the right side. So through the use of logs, we're able to cancel them out. Okay, so we're basically going to have x squared minus 4x equals 2. Okay, so we have a quadratic. So like I said, we want to make sure x squared stays positive, right? Do all my movement, make sure x squared stays positive though. Yeah, and make sure everybody's on one side and 0 is on the other. So either I move these two, the x squared and negative 4x to the right, or I move the 2 to the left. But I want to make sure I keep this guy positive. And if he's positive right now, he's going to stay put. I'm going to move the 2 to the left side if that's the case. So since the x squared is positive where he is, I'm not going to move him at all. Let's make that negative 2. Yeah, that 2 go on the left side instead. Okay, so we get x squared minus 4x minus 2 equals 0. And we have a quadratic that we can either use one of three strategies, right? Factoring, complete the square, or quad formula. Okay, and unfortunately this time there's no two numbers that make negative 2 when you multiply and negative 4 when you add, so factoring is out of the question. Okay, so maybe you might want to do complete the square, right? Remember that one? And if you forget how to complete the square, that's also a video topic on one of my review videos that I have made as well. So just look that up. Okay, so we're going to do complete the square. So first thing for complete the square is we want to see if this negative 2 is a number that should be there. That completes the square, basically. So when we run the test, right, the test goes like this. Grab your middle term. Did I change it to purple? Yeah, grab your middle term, cut it in half, and then square it. And we get 4. So, is this a 4? No, that's a negative 2. So there should be a 4 sitting right next to the negative 4x to complete the square. So because that's not the case, we have to politely tell negative 2 to go on the other side. So how do I politely tell negative 2 to go on the other side? How do I make him go on the right side? Well, just add 2. So add 2 on the left side, add 2 on the right side. And when that happens, I'm kind of running out of space over there, so let me just shift to this right side. So I get x squared minus 4x equals 2. And here's where you're going to say, oh my goodness, we just had the 2 on that right side and now you moved it back on the left side. Oh yeah, well we didn't know what technique we were going to use when we solved for this quadratic, right? So I mean, yeah, if you really paid attention, maybe you could see in the future and you could see that this was coming anyway. Yeah, but we really didn't know which technique was going to actually work. So Yeah, sorry if you had to do the 2 back there where it came from. Yeah, so it seems like it was pointless, but it's all about the realization of the numbers and understanding of the process. Okay, so let's put the number that should be sitting right next to that negative 4x, and that will be a 4, a positive 4. And don't forget, whatever you put on the left side, you have to put on the right side. So I put a positive 4 on the right side also. Okay, so what do we have? Well, we can now do our factoring, right? What 2 numbers make 4 when I multiply and negative 2 when I add? And this is where you hopefully say negative 2. So negative 2 is the combination that works. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4x. And like I said, yeah, this is complete the square. This is a topic for a video I already made and I posted, so just look that up for complete the square. Okay, and on the right side we get 6. All right, so let's start cleaning up this left side. Let's call this x minus 2 squared, yeah, because they match, so I can put them in squared, and it equals 6. Okay, and since I'm solving for x, I want to get rid of the square, and the only way you can get rid of a square is through a square root. And this is where I said earlier in the year, right? Once you put square roots on the left and the right side, you also have to put the plus minus. Don't forget about that, the plus minus. Okay? So left side becomes x minus 2. Right side becomes plus or minus square root of 6. And unfortunately, 6 cannot be broken up any smaller so that I can circle anything. Because the only way 6 can be broken up is going to be 2 and 3. And 2 and 3 cannot be circled. So I'm not going to circle anything for this square root right here. It's going to stay as is. But I do have to get the x by itself to get. That's still my mission, get x by itself to solve for x. So add 2 both sides. And I get x equals 2 plus or minus square root 6. And there you go. Add that to the line right here. 2 plus or minus square root 6. And number 3 is done. Okay. All right, let's move on to number 4. Okay, so now we have their first curveball that they're going to throw at us. Okay, notice what you see on the left and the right side. Do they match? No, they do not match. Okay, and because they do not match, you cannot just go ahead and cancel stuff out. Yeah, because they don't match. We cannot use logs to cancel out the left side and the right side, the bases, because they don't match. So instead, we're going to try to force them to be the same. Okay, so you're going to have to do some cosmetic surgery. You're going to have to change this 64 so it becomes a base 2 instead. Yeah, so this is where you really got to know your numbers, and this is where I usually get the kids asking me, hey, how do you figure this out? And that's why I don't let you guys use the calculator for the first 3 quarters, because I need your brains to be sharp, and I need them to understand numbers. That 64 is the result of 2 multiplied 6 times. Okay? So 64 is the result of 2 multiplied 6 times. So I'm going to rewrite this problem as 2 to the 4x minus 2 power equals 2 to the 6 power. Okay, so all I did was I rewrote the 64 as 2 to the 6 power. And now look what you see on the left and the right side. Do you see a matching base? Yeah, base 2, base 2. So now they match. They didn't match before, so I made them match. And since they match now, I'm going to use logs to cancel them out. And when the logs do their job, they're going to cancel out the base 2's. And all I'm going to have left is 4x minus 2 on the left side and equals 6 on the right side. Okay, so now this problem got a lot easier. It didn't start off easy. Yeah, they threw a little curveball at us, but it ends up being business as usual. Okay, so we're going to solve for x. So we're going to, well, since it's not a quadratic, we just got to get x by itself on this left side. So add 2 on both sides. Okay, when we don't have quadratics, solving for x is a lot easier. Yeah, you just got to get x by itself. When we have quadratics, then life gets a little bit more complicated. So left side 4x, right side 8. Okay, now we're going to divide by 4. And we get x is 2. Okay, so it didn't start off easy, but it ended up very familiar for you. Okay, so that's the trick though. You gotta make them match. Okay, so let's look at this next one. So you really gotta know your numbers. So if you know your perfect squares and your triples, then these numbers will get easier. And you're gonna say, how do you get them? And I'm gonna just say, well, I just play with numbers all the time. I don't use my calculator a lot. I use my brain. Okay, sometimes it's harder that way, but when you get to these kind of problems, then it makes more sense as far as why I made you guys not have a calculator for the first 3 quarters. Okay, so right now they don't match. This is a 36, that's a 216. Okay, and last time we only had to change one number. We just had to change the 64 to become a 2. Okay, you're gonna hate this, but yeah, this is gonna be their next curveball. You gotta change both sides so that they match at a totally different number that neither of them are at right now. So it's kind of like doing common denominators, yeah? Sometimes your denominator doesn't match at either number, but they match at a totally brand new number for both of them. Okay, so that's kind of like what we're doing here. So it's not going to match at 36, it's not going to match at 216, but it's going to match at a totally different number that's not presently on the paper or on the board or on this screen. Okay, and that number is going to be a 6. So watch what I do. I'm going to rewrite 36 as 6 squared. Okay, but keep in mind now that 2x is still out there. Okay, so that 2x is still there. Okay, and 216 is the result of 6 cubed. And keep in mind, the x minus 1 is still out there. Okay, so following along so far? Okay, so here's the part that we never did this particular step yet. Okay, so we have 6 squared. Yeah, the square is a power, the 2x is a power. So these two powers are going to multiply to each other. Okay, so this is going to turn, this left side is going to turn into actually 6 to the 4x power. The right side, okay, you got to be real careful because this is not usually how we write distribution, right? Usually we have a parentheses around the x minus 1, but there's no parentheses, but there's still going to be distribution. This 3 is going to multiply to the x. This 3 is going to multiply to the negative 1. So when I change this right side appearance, it's going to be 6. The base is still 6, and it's going to be 3x minus 3. Okay, so that's an additional step that we didn't have in problem 4. We didn't have to do this step in problem 4 because we never had a power that was left on the outside after we made that switch. It just became 2 to the 6. It was a nice clean break. Okay, so you have to add in this extra step. Okay, so just rewind this video as many times as you need so you can see what happens. Okay, and now we're going to pretty much be business as usual, right? You see your matching bases, so we're going to use logs to make them cancel out. And when the logs cancel out the base 6's, we get 4x on the left. We get 3x minus 3 on the right. Okay? And then this is not a quadratic, so we don't have to do any factoring or complete the square or quad formula. This is just regular plain old x. Yeah, so we're going to start getting the x's on one side and the numbers on the other. So let's make this 3x go to the left. So subtract 3x on both sides. Okay, so left side we get regular plain old x. Right side we get negative 3. And boom, this problem is done. Okay, so once you get the bases to match, yeah, hopefully you're home free. I mean, yeah, if you have a quadratic, it's going to make your life a little bit more difficult, but hey, we've been solving quadratics ever since first quarter, so you should be good to go, please, right? Okay, all right, so number 5 is done. Is there a number 6? Let me just see. Or is it homework problems, right? Oh, there is a number 6. Okay, so once again, we want to make the bases match, because once again, we don't have them matching. This is a 9, that's a 27. They don't match. Okay, so is it gonna, can we turn? Can we rewrite 27 as 9 to the something power? Or do both left and right side bases have to change into a totally different number? Okay, so yeah, in this case they do. Okay, because there's no way you can write, there's no number that's like, you cannot do 9 to some kind of power equals 27, right? And a lot of kids say, oh yeah, 9 to the third power makes 27. No. This is 9 times 9 times 9. If you say 9 to the third power, that's 9 times 9 times 9. I know why you put 9 to the third power, because you think 9 times 3 is 27, but please don't make that mistake. Okay? Remember now, you're making an exponential type number, yeah? Where you got to multiply it that many times to get 27. So 9 to the third power, you cannot do 9 plus 9 plus 9 either. That doesn't work. That's not how exponents work. All right? So you got to change them both into base 3's. So this left side, 3 squared, okay, and then we have x squared stuck outside, and on the right side we have 3 to the third, and we have, what is that, x plus 3 stuck on the outside. Okay, so now let's combine our powers. So just like in problem 5, we've got to combine our powers, so we're going to get 3 to the 2x squared power on the left side, and on the right side we're going to get 3 to the 3x plus 9 power. Okay, so now our bases match, right? Our bases match, so we can use logs to make the base 3's disappear, right? And when the base 3's disappear, we get 2x squared equals 3x plus 9. Okay, so we don't have a regular plane on x this time, so our solving is going to be a little bit more complicated, so we got to do quadratics, right? So we got to make sure, right, x squared, the x squared guy has to stay positive, and we got to move everybody to one side or the other. Okay, so right now, is my x squared guy positive? Yeah, he is. So do you think he's going to move? No, he's not going to move. He's going to stay put. He's going to anchor down. Yeah, we're going to move the 3x and the 9 to this left side because we want to keep that x squared positive. Yeah, you don't want to make that x squared negative at all costs. You do that, game, it's not game over, but as far as your life in this problem, it's going to be way harder. Yeah, so try to keep that x squared positive at all costs. Okay, so we get 2x squared minus 3x minus 9 equals 0. Okay, so you're going to have to do one of three techniques. You can either factor it, which since there's a 2 in the front of the x squared, that's going to imply guess and check factoring. Will guess and check factoring work? It might. Yeah, it might. I think it is, but yeah, I don't think you want to do guess and check factoring unless you really want to. So you're better off with just going with quad formula. Okay, and quad formula is going to be the best because you can't do complete square. I mean, you can, but you got to get rid of this 2, and then you got to divide everybody else by 2, and then you got to cut them in half in squares. So that's going to make things real ugly. So you're better off just going with quad formula. So A is 2, B is -3, and C is -9. Okay, so since this is a quad formula problem, like I said in the review video for quad formula, yeah, whenever we do a quad formula problem, here's what I always do. I write the quad formula. So -b over 2a plus or minus square root of b squared minus 4ac over 2a, right? So every single time I do a quad formula problem, I write it down. Okay, so let's start plugging and playing. So x equals negative, and then b is -3, so I got 2 negatives in this first fraction right now, and 2 times 2. And then plus or minus, ooh, sorry, you can't really see that minus sign yet because it kind of joined together with the division bar, so you can't kind of see it, but it's there. Sorry about that. Okay, so b squared, so that's going to be -3 times -3. So -3 times -3 minus 4 times a times c, which is -9. Okay, around out of space, let's make these lines longer. Okay, so b squared, -3, -3, minus 4 times a times c. Okay, write everything down correctly. The bottom is 2 times 2. Yeah, just want to make sure I plug in everything correctly because I don't want to realize I plugged in something wrong and I'm already at the end of the problem. So I just want to make sure I plugged everything in correctly. Okay, so first fraction, the negative makes a positive, and then 3 on the top, 4 on the bottom. Okay, so that was pretty easy. Second fraction, a little bit more stuff to happen to work out. So -3 is 9. And then -4 times 2 is -8. Yeah, -4 times 2 is -8. And -8 times -9 is +72. Okay, and all over 4. Okay, this time I made the lines too long. Yeah, last time I made these lines too short. And this time I made it too long, so good thing I have an eraser. Okay. Alright, so let's start playing with this second fraction. So first fraction stays the same, +3/4. So I'll just stop writing the positive sign for now because you don't need to if you don't want to. This is square root 81 over 4. And oh, wow, I think 81 is a perfect square. Yeah, and that will be a 9. So x equals 3/4 plus or minus 9/4. Okay, and okay, you can't just leave your answer like this now, because a lot of kids, they like to leave their answer like this without even realizing that these denominators match, and actually these guys are like terms also. They can be combined, so they're going to actually make something else. So let's get some more space. Okay, so what do we have when we add these guys up? So basically you got to remember now we have two different 9/4. We have a positive 9/4 and a negative 9/4. So be careful with that. So we're going to go x equals 3/4 plus 9/4. And on the side here we're going to go x equals 3/4 minus 9/4. So that's your plus and minus 9/4. So this side is going to be x equals 12 over 4, which is 3. And the right side is going to be x equals -6 over 4. Yeah? And that's going to make, simplify that fraction, -3 over 2. Okay, sorry to scrunch things in the bottom. Okay, so let me zoom out here so you can see the whole thing. And fit to height. Okay, so there's the whole problem. Oh, forgot to write the answers on the line, so put them in numerical order. So negative 3 over 2, comma, 3. Okay, and that's the video. I hope you enjoyed it. I know it's kind of on the longer side, sorry about that, but yeah, this is a lot of computation for some of these problems. So good luck, and I'll see you at question and answer. Bye-bye.